Okay, so my name is Loïc Roguin. I've been writing Erlang code for about 2 years now. I'm principally the author of the Cowboy project. You often see me wearing a hat to support my project, but not today. Today I will be speaking about another project called Ranch, which is based off Cowboy. And Ranch is what we call a TCP acceptor pool. I will explain what it is. So today I've been lazy. I don't have any slides. I will be simply writing code to demonstrate how it works. So to start with, I've simply created a new project. You can see the files in essence here. We simply have an application and a supervisor. They are both empty. And the extra file is the Ranch FTP protocol that I will write, but it is empty at the moment. So this is a working Erlang application. As you can see, we start Ranch here, and we start. Then the Ranch FTP application, this is the application that we are going to write. So I chose the FTP protocol to demonstrate this because I want to show two things. I want to show how Ranch allows you to write network applications, and I want to show how you can use binary pattern matching for writing text protocols. So let's start by compiling and running it. So I'll be writing this command a lot. Okay, so this starts and this does nothing. If I try to connect, I don't have a port yet, so I can't. Okay. So first we need to start what I call a listener. By default, Ranch does exactly nothing. It just starts and waits for you to start a listener. A listener is simply a set of processes that listen on a port and accept connections. So generally we do that in the start function of the application. This isn't the best solution, there are other solutions, but this should be the easiest for the moment. So we simply call Ranch start listener. So we give it a name, FTP for example, and a number of acceptors, which is the number of processes that will be accepting the connections. For FTP, we don't really need a big number. This is mostly for performance reasons, especially when you do it with HTTP, where you can have a lot of requests at the same time, and you want to accept them as fast as possible. But here it doesn't matter much, so 10 will do. Then we tell Ranch that we want the acceptor to be for TCP transport because we support both TCP and SSL connections, and we give it the options, that is the port we listen on. We will use 21. And then we give it the module that will be handling the protocol code, that is Ranch FTP protocol that I will write after that. And this one doesn't take any argument. So with this simple command, we start a set of processes there. For this, there will be 13 processes, including 10 acceptors, one supervisor for the acceptors, one supervisor for the connections, and one supervisor for the whole listener. So this is very important because this is usually code that you have to write an architecture yourself. Here you can simply run this function and Ranch will take care of everything. And if a process is crash, Ranch will restart it if it's an acceptor, and if it's a connection, we don't need to worry about it. So let's see if it's complete. Yeah. And so if I try, oh, I have an error. Why? Because simply I haven't defined the Ranch FTP protocol yet. So let's do this. So this is an opti module. Ranch uses a very simple interface. You only need to implement one function. That function is called start link and cut 4 arguments. These arguments are the PID of the listener, in case we need to talk to it, and we are going to be required, and the transport socket and transport. Transport is simply a Ranch TCP that we specified earlier, and the options that we don't care about here because we didn't set in. So we simply start a new process that will handle this. And we pass it all these arguments. Okay. So now we need to define the function init that will be used to initialize our connection. I'm sorry, I'm a bit sick. So init receives 3 arguments: listener, PID, socket, and transport. The first thing you need to do when you accept a connection with Ranch is to tell Ranch that it's okay, you have taken control of the socket, and Ranch can move on accepting other sockets. So to do this, we simply call Ranch accept ACK with the listener PID. And now Ranch can continue accepting the sockets. Of course, this only blocks Ranch on one acceptor. The other acceptors can still accept at the same time. So doing this, we make sure that both sides understood that they received the socket and that the ownership of the socket was transferred. And this function will stop there for now. Let's see if we can connect. No, I didn't export the function. Okay. Oh, yeah, I have a bit too much warnings, too much. My warnings are considered errors, so, okay. Oops. Okay, FTP localhost 21. Okay, so this time we don't have an error. We simply have the FTP client telling us that the remote server closed the connection. And that's what happens when this process stops. Erlang takes care of cleaning up the socket. So now that we have a connection, I can demonstrate better with an EO format. Here. Okay, so we have test, so the connection happens and then the process stops, the socket gets closed. So now let's receive. FTP first sends a message to authenticate the user. No, sorry. First, we need to send the client a message to welcome him. So to do this, we simply reuse the transport. The transport and socket variables that we received. Hello. And most of the ranch code will be like this. We use transport and call a function, passing the socket and a few other arguments. So here we pass what we want to send, which is, I don't recall, so let me look at my cheat sheet. 200, okay, so we tell it, we give him a proper response code. 200 means everything well, and a message. Okay, and all FTP messages must finish with a line break. So let's see if that changed anything. Okay, we received something. And now the FTP server asks for a username. So this is better. The next step in FTP is that the client will send a username, and depending on the username, we will ask or not for a password. So here we won't ask for a password because it's a bit too complicated. But let's see if we can receive the username. And to do this, we can simply call transport repeat socket. The second argument is the number of bytes we want to receive. We want to receive whatever comes. And the timeout, maybe a bit more. Okay. And printing data. Okay, so we received user SN, so that's me. And then we stopped, so that's why the FTP client couldn't connect. So let's simply ignore, we will pass the response, ignore it, and send the correct reply to the client. So I will write a new function, auth, to authenticate the client and pass it the data I received. Here there's something very magical about Erlang. It's that you can simply pattern match the variables, the arguments given to a function directly in the function class. So here I can do this to identify that I properly received a user command. And then whatever is after is the username followed by the line break. So if I do this and print rest, oops. I should have my name printed on the left. Okay, let me disable this. Okay. Yes, okay. So we can extract easily informations in text using binaries. And this makes writing the protocol much easier. We will see that with all the other commands following authentication. So the user is allowed. Let's inform the client, which is using this good number. I'm not sure. I don't remember what the text should be, but it should be okay like this. Let's see. Ah. Okay. So now we simply want to loop over all the following commands. And this is easily done because we simply, in this protocol, we simply receive a command and do something and send back a response. So to loop, we'll simply use a function called loop. This function will receive data. So we will call transport weekly, but we want to make sure we properly detect disconnects at this point. So let's write a case, transport weekly. If I receive data, I want to handle it. So I simply pass it to handle function. And if not, it's an error, and I want to inform us that something went wrong, the client disconnected. Okay. And the handle function for the moment will simply accept all data and print it on the terminal. Okay. Okay, so as you can see, I received already a command before I type anything in the FTP client, which is sys. This one is about it's the client asking the server what it runs on, what version it is this time. So it's not very important. But if, for example, I do ls, oh yeah, I forgot one simple thing. Can you see it? I did not loop. Okay. So by recursively calling this function, I can simply loop over and over until there's an error. So let's try again. Okay. Oh, something. I don't have a prompt. Yeah. So I did something wrong. Let me check. Oh yeah, I did not, I'm sorry. I need to inform the client after each command that I received the command, and even if I didn't understand it, I need to tell it, okay, I don't know this command. So I'll be passing socket and transport here, and simply add transport, send, This is pretty much the same code as HTTP for the most common ones. Okay, so doing this, we shouldn't wreck the client. Okay, and if I do ls, I receive two commands. If I do wd, okay, I receive more commands. Okay, so doing this, we can now write the FTP server. Yeah.
Would you mind bringing up the document for the number?
Oh, okay. Like this. Okay, so by doing this, you can write your server command by command and always know when a client sends a command that you don't know yet. It's very incremental. You don't need. I didn't read much of the specification to come to this point. I don't really need to because the client tells me most of everything. there's one last thing I want to cover, which isn't really needed here because of how this particular FTP client is written, is that sometimes you might receive for this protocol or another commands in more than one packet or many commands in a single packet, so you need to bufferize and properly cut the parts. So to do this, we simply need to add a buffer to our loop, which is empty to begin with. And when we receive, we add the data to the buffer. So we have buffer 2 like this. We append, this is a pretty cheap operation. And then we check if we have a complete packet in our buffer. So to do this, I will write one last function that I will call split. So this command will send, this function will return the commands it found and the rest of the data that is still to be processed. Okay, so this one is pretty simple because what? Oh yeah. Oh, sorry. Okay. So because FTP is using lin breaks to separate the commands, we can simply use binary split on data, passing this as a delimiter, and doing this should work. And then the commands need to be processed. We might have 0 or more, so we simply write a list compression for each of the commands found in the list. We simply call the function handle command like this. Okay, so this means for each of the commands, apply handle socket transport C to the command. And that's it. You have pretty much all the pointers you need to know. Oh yeah, sorry. I'm not actually going to run this.
You want rest of that?
Oh yeah, sorry. Thanks for following. So that's all you need to know to write your own protocols or implement existing protocols. This works both for servers, in this case. Using Ranch, as you can see, is pretty much straightforward. You actually don't need to care about Ranch. Just 5 minutes. And this makes, I think, programming network protocols very easy. So do you have any question? No? No question? Oh yeah?
Why did you call it Ranch?
Okay, so I called it Ranch because it comes off the Cowboy project, which is an HTTP server written in Erlang. And this project is called Cowboy because it's kind of an opponent to Apache.
Are you sure that the split command is right? Should that not be returning a list and a tail rather than a tuple? Or
Oh yeah, it's not right.
It's a list with a tail.
Yeah,
it's
it's
that's going to return you a list.
Let me check. Oh yeah, it returns parts.
Yeah,
so
it's going to be
okay. We can match it here.
Yeah, so you want to match that against a list and a tail.
Well, this isn't right. Okay, don't follow this. I will write a blog post to put the correct version So hopefully.
Any more questions?
Any more questions? Okay, thank you.